In this video lesson, we're going to review how to factor polynomials. So we're going to factor completely on each example. So first, let's talk about what factoring means. Factoring is the opposite of distributing or foiling. And distributing means that we are multiplying. So factoring, we're going to divide out. So factoring is the opposite of distributing. Looking at the first two terms, when I factor, I look to see what those two terms have in common. If there's a number I can divide from both, or a letter I can divide from both. Looking at example 1, they have in common a 4 and an x. So I'm going to divide that from each of the terms. What's left goes in the parentheses. 8 divided by 4 leaves me with 2. X squared divided by an x leaves me with an 1x. 20 divided by 4 leaves me with a 5, and those x's cancel. This is all I can do on example 1. So this is called a greatest common factor, or you might have heard it as a GCF. If I want to check to see if my answer is correct, I could distribute everything back out. So 4x times 2x is 8x to the second. 4x times 5 is a 20x. And I see that that is what I started with, so we must have factored correctly. Looking at example 2, I want to see if there's a GCF again. So is there anything that those three terms have in common? None of them have anything in common. So when I factor, I'm going to do the opposite of distributing, which could also be the opposite of foiling. For our second example, this is a quadratic trinomial. So whenever we have a quadratic trinomial, there's two methods I can do here. If my front term is a 1, then I'm going to look for two numbers that multiply to this last number, or you might have learned it as that's the product. And those two numbers are going to add to this middle number, which is a -1. That number you might have learned as the sum. So I need two numbers that multiply to -6 that also add to -1. Those two numbers would be -3 and +2. We are going to have an x and an x because we have an x squared in the front. So this is the opposite of foiling. So anytime there's three numbers or three terms, if the first one is an x squared and the middle is an x, you just have to find numbers that multiply to the third number that also add to the second. So here are my factors for number 2. If I'm foiling to check this answer, that means first, outer, inner, last. So if I did the first term times the first term, that's x squared. Then if I do the outside terms, x times +2x is a +2x. I in FOIL stands for the inside terms. -3 times x is -3x. And the L in FOIL stands for last times last. So -3 times 2 gives me -6. Then when I combine like terms, these two middle terms add to equal -1. So that is why we look for numbers that add to the middle and multiply to the third. Example 3 is called a difference of squares. And that's because we have a difference or a minus sign, and the two numbers are both perfect squares. So anytime we have a difference of two perfect squares, you just square root each of the numbers. So x squared, if I square rooted it, gives me x and x. 16, if I square rooted it, gives me 4 and 4. 1 is always plus and 1 is always minus. This is a pattern for any example where we're factoring a difference of two perfect squares. If I foiled this back together to check, first times first would be x times x, which is x squared. Our outside terms would give me -4x. Our inside terms would cancel because we get a +4x. And last times last is -16. So when I combine like terms, these add to give us 0x. Or notice that the x term is missing. So if you wanted to look at that instead of as a difference of squares, if you wanted to look at it as a quadratic trinomial, you could put in the x term that was missing with a 0 in the front. And then just find two numbers that multiply to -16 that also add to 0. You'd find that the numbers are always the same, just one is plus and one is minus. Or you just remember that the difference of squares is a pattern. One's always plus, one's always minus, and the factors are the same. So now if I look at 4 and 5, it's going to be a combination of the three types we've looked at so far. So if I look at number 4, first see if there's a greatest common factor that I can divide from all the terms. Looking at example 4, they can all be divided by 1x. So if I divide everything by 1x, I'm left with an x squared plus 2 and 1x and minus a 15. Then I have a quadratic trinomial left over. So I can factor this further the same way I did on example 2. I have an x squared, so that tells me my letters are x and x. And I'm going to look for two numbers that multiply to -15 or have a product of -15 that also add to 2 or have a sum of 2. So numbers that multiply to -15 could be 5 and 3. And because that number is negative, one of these numbers is a positive, one of them is a negative. So for them to add to equal +2, 5 has to be positive, 3 has to be negative. And here are my factors for number 4. And if I wanted to multiply them together, I would first FOIL these binomials and then multiply the x back in. And I would get what I started with. On example 5, we also have a greatest common factor. All of these terms can be divided by an x and a 2. So let's start there. So if I take out the 2 and the x, that's in the front, I am left with a 2x squared minus 3x minus a 20. So now what I have left is a quadratic trinomial, but the difference is my leading coefficient is a 2, not a 1 like example 2 and example 4 were. So I do something a little bit different when it's not a 1. I'm going to finish this example by doing what's called factor by grouping. So to continue with factor by grouping, I'm going to take the first term and the last term and multiply the numbers in the front. So 2 times -20 gives me -40. -40 is now my product. So I'm going to look for numbers that multiply to -40 that also add to this middle number of a -3. So numbers that multiply to -40 could be -4, +10, -5, +8, -2, +20. And if I look at this list, I'm looking for numbers that are going to add to -3. These two give me a close answer, but the sign is backwards. So if I switch the sign and make 5 positive, 8 negative, then that'll work. So what I do with that, I'm going to change my -3x in the middle to be a +5x minus 8x. And the reason I can do that is because those two numbers are going to add to equal -3x. And now I have 4 terms. So when I continue, I'm going to continue with those 4 terms by factoring by grouping. So I'm going to group the first 2 terms, and I'm going to group the last 2 terms. And I do a GCF for each of the groups. This 2x just hangs out in the front, so nothing happens there. If I look at the first group, they both have an x in common, that's it. So if I take an x out, I'm left with a 2x plus 5. My second group, they can both be divisible by a 4. I'm also going to do a negative 4. So if I divide by negative 4, I'm left with positive 2x and a positive 5. For factor by grouping to work and to continue, what I have in the parentheses must be identical, which they are. If not, then I have the wrong numbers that add to the middle and times to that product. So since 2x plus 5 they have in common, I now look at each of the groups. So I look at group 1, I look at group 2, and I see what they have in common. This time they have an entire set of parentheses in common. So I'm going to take a 2x plus 5 away from each group. This 2x in the front is still in the front. And what's left that I haven't scratched off goes in the second set of parentheses. So I have an x and a minus 4 left. So here are my factors for number 5. And if I wanted to check it, I could FOIL the two binomials together first. I would get these 4 terms. I would add like terms, so then I would have these 3 terms. And then I would multiply the 2x back in, and that would put me back at what I started with for example 5. So anytime you have a quadratic trinomial and the front number is not a 1, you want to do that method. On number 6, we're going to start by seeing if there's a greatest common factor. Both of these terms can be divided by a 5, so we'll start there. If we take out a 5, we're left with x cubed minus 8. And then I see I have a difference, but they're not squares. They happen to both be cubes. So when we were in Algebra 2, there was a difference of cubes factor pattern, like there was for a difference of squares. And you maybe memorized that pattern and then haven't used it in a while. So if I have a difference of 2 things that are both perfect cubes, then to factor, there's a binomial times a trinomial. The binomial is going to be a minus b. The trinomial is going to be a squared, ab in the middle, and b squared at the end. To figure out the signs, the first one in the binomial is always the same as what you started with. The next sign is opposite, so that would be a plus. The third sign is always positive. You might have heard of an acronym SOAP that would help you memorize that. S stands for the same, O stands for the opposite, and AP stands for always positive. There is also a factor pattern if there's a sum of cubes. That is also a binomial times a trinomial. So the binomial would be a plus b. Notice that the first sign is the same as what I started with. The next sign is opposite, so this would be a minus. AB is still in the middle, and the third sign is always positive. So if we look at that one more time, the first sign is the same, the next one's opposite, the third one's always positive. So x cubed is a cube of x. 8 is a cube of 2. So when I factor, I'm going to have a binomial times a trinomial. If it's minus, the first sign's minus. The next sign is the opposite, so plus. The third sign is always positive. X cubed and 8 are cubes of x and 2. So that's how I figure out what my a and my b are. You just cube root each one. So if this is my a and this is my b, then I use those to figure out what goes in the trinomial. A squared is x times x, so that would be x squared. AB is the middle term. I'm going to multiply x times 2, and I can ignore the signs because they're fixed. X times 2 is the same as 2x. My last term is b squared. If b is 2, 2 times 2 is 4. And I can't factor x squared plus 2x plus 4 any further because there are not two numbers that multiply to 4 and add to 2. If there was, this factor pattern would go further than the a squared plus ab plus b squared part. So this is my answer whenever it's a sum or difference of cubes. On example 7, I have 4 terms set up. So the only way I can factor this one is by doing that grouping method that we did on the last slide. So if I'm grouping, I'm going to group the first 2 and the last 2. The first 2 can both be divided by a 3 and an x squared. So I'm going to take out a 3 and an x squared from both terms in the first group. I'm going to be left with a 2x minus 1. The second group can both be divided by a 5. And I'm going to make it a positive. If I don't get the same exact numbers in the parentheses, I'll change it to a -5 and see if that works. 10x divided by 5 leaves me with a 2x. -5 divided by 5 leaves me with a -1. And remember, I can only continue with factor by grouping if what's in the parentheses matches identically, which they do on this example. So because they have a 2x minus 1 in common, take that from each, and whatever's left goes in your other set of parentheses. So I get 3x squared plus 5. And I can't continue factoring in either set, so these are my factors. And again, I could FOIL this back together to see that I start with those 4 numbers that we started with. For my last example, start with there's 3 terms and see if there's anything that they all have in common. On example 7, I did not see if there was a greatest common factor between all 4, but we should look at that always first. So looking at 8, I can divide all 3 of these by a 2. So first take out that 2. By taking out a greatest common factor, it does a few things. It makes all of our numbers much smaller, so factoring gets easier when we're using smaller numbers that we're used to using a lot. So always take out that greatest common factor. Then I see I'm left with 3 terms. So we have a quadratic trinomial, and my leading term is not a 1. So we're going to do this grouping method again for example 8. So if I do that method again, I take the first term and the last term, multiply them together, we have a product of 8 now. I then look for numbers that multiply to 8. So 2 and 4, 8 and 1. Those numbers need to add to the middle. So that would be 8 and 1. So I'm going to change my 9x to be 8x plus 1x. And the reason I can do that is because 8x plus 1x adds to equal 9x. Then I just do factor by grouping the rest of the way now that I have 4 terms. So if I look at the first 2 terms and I look at the last 2 terms, I look to see what each group has in common. So group 1 can both be divided by a 2 and an x. So this 2 is from the beginning in the front, and then I'm going to take out a 2x from the first 2 terms. That's going to leave me with 1x plus 4. My second group has nothing in common, so I'm just going to divide out a positive 1. Then I'm left with an x plus 4, which happens to match what I've already done. So because these match, I can continue. If they didn't match, then I would have to figure something else out. So I have a 2 in the front from the beginning, and then they have an x plus 4 in common if I look at group 1 and group 2. If I take away an x plus 4 from both groups, or divide it from both groups, I'm left with a 2x plus 1 in my other group. And these are my factors on number 8. And that's every type of factoring that we have done.